Next problem, difference of two standard deviation. In a survey of income of two classes of workers, two random samples gave the following details. Examine whether the difference between one means second the standard deviation are significant. So given table, size is 100, so n1 equal to 100, n2 is equal to 100. Mean, so x1 bar is equal to 582 and x2 bar is equal to 546. Standard deviation S1 is equal to 24, S2 is equal to 28. Examine also whether the first sample could have come from a population with annual mean income of 500 rupees, right? So given sample N1 and N2 100 each, means we know standard deviation, right? First one taking means, right? So defining hypothesis, null hypothesis, H0 mu1 equal to mu2. There is no significant difference between means. Alternate hypothesis, there is a significant difference between means. Two-tailed test we are using, right? Let the level of significance be 5%. Test statistics Z is equal to formula difference of two means formula, right? x1 bar minus x2 bar divided by root of s1 square by n1 plus s2 square by n2. Substituting the values, 582 minus 546 root of 24 square by 100 plus 28 square by 100. So that is equal to 9.7617. Calculated value of Z is 9.7619. Tabulated value of Z is 1.96. Conclusion, calculated value is greater than tabulated. Therefore, null hypothesis rejected. Therefore, there is a significant difference between the means. Next we are going to see the standard deviation defining the hypothesis. There is no significant difference between the standard deviation, right? Alternate hypothesis, there is a significant difference between standard deviation. So we are using two-tail. Level of significance 5%. So test statistics, we are using difference of two standard deviation test statistics formula, which is equal to s1 minus s2 by root of s1 square by 2n plus s2 square by 2n2. Substituting the values, 24 minus 28 by root of 24 square by 2 into 100 plus 28 square by 2 into 100. So you will get minus 1.5339. So calculated value is the modulus value of test statistics. So you will get 1.5339. Tabulated value is at 5% level 1.96. Conclusion, calculated value is less than the tabulated value. Therefore H0 is accepted. So there is no significant difference between the standard deviation, right? Suppose the first sample could have come from a population with annual mean income of 500 rupees. So given sample size n1 equal to 100, n2 is equal to 100. Sample mean x1 bar which is equal to 500 and x2 bar which is equal to 546. First sample could have, they have given, right, with annual mean income 500. Therefore x1 bar is equal to 500, right? Standard deviation everything same. So mean, first we are defining for mean, we are going to find for mean. Defining hypothesis, null hypothesis, there is no significant difference between mean. Alternate hypothesis, there is a significant difference between mean. So test statistics, Z is equal to x1 bar minus x2 by root of s1 square by n1 plus s2 square by n2. Substituting the value, right, here we are taking x1 bar is equal to 500 minus 546 by root of 24 square by 100 plus 28 square by 100. So value is minus 12.4736. So calculated value, modulus value of test statistics Z, that is equal to 12.4736. Tabulated value 1.96. Calculated value is greater than the tabulated value. Therefore H0 is rejected. So there is a significant difference between mean. Next, standard deviation, there is defining hypothesis, there is no significant difference between standard deviation H0, right, null hypothesis. Alternate, there is a significant difference between the standard deviation. So test statistics, Z is equal to s1 minus s2 by root of s1 square by 2n1 plus s2 square by 2n2. Substituting the values, 24 minus 28 divided by root of 24 square by 2 into 100 plus 28 square by 2 into 100. So that is the same value. So taking the modulus value, calculated value is equal to 1.5339. So calculated value is less than tabulated, therefore H0 is accepted. Thanks.